Assalamualaikum. My name is Muhammad Afiq Izzuddin. Okay, so today I will explain a little bit about our project introduction. So in electrical distribution, the transmission line has the major role in power transmission to deliver the electricity for consumer in daily life. At the power transmission line cable, there has the insulator to prevent the current flow, and for the mechanical support, therefore the insulator must be safe and long-lasting for operating in terms of avoid water problems such as the flash over voltage, the transients over voltage, and the damage occurs in the system. Okay, so next is our problem statement. In this modern era, electricity has been used for many types of equipment. Therefore, the need for electricity is increasing rapidly every year. A grid network has been used to send the electricity from the power plant. Usually, the supply voltage is around 132 kV to 500 kV. Okay, so next is our objective. Okay, for our first objective is to design new suspension types of overhead line insulator using polymeric material that be used in 132 kV supply. And next is design, simulate, analysis the new insulator using advanced software. And our last objective is to propose a new standard safety code when conducting the test in the lab. Okay, so next is our scope of work. Okay, so our first scope is system is a high voltage which 132 kilovolt, and next is design the overhead insulator using AutoCAD software, and after that we using FEMM software to simulate the new insulator design, and last analyzing the performance of insulator exposed to environmental change. Okay, so our yearly outcome is better understanding in high voltage transmission and overhead line insulation method, the type of material that can be used for designing the overhead line insulation, and last but not least is the capacity and endurance of material that can withstand high voltage that exceed 132 kilovolt. Okay, so I will pass to.
Assalamualaikum warahmatullahi wabarakatuh to Dr. Lee. My name is Syed Hassan Husaini bin Syed Omar. My material number is CE190050. I will continue the presentation with the simulation for the spring insulator, and I will use the FEMM software to conduct the simulation. And I have put materials in this simulation for the polymer, steel, and air. For the steel, the relativity I put 1, and for the polymer I put relativity is 6, and for air is same as 1. And at the above we put as the material as earth, and for the lower one is the electricity for this life. And as we run the simulation, we can see the result. Okay, we create the mesh to 25,741 nodes, and the running simulation we have no problem over here. And this is the FMM output for the HP test 1. So we can see the field intensity. Okay, this is the field intensity for this for the first one. So as we can see, near to the spacing from the insulator and the steel, we have what we can see, a pocket of air between the insulator and the steel. You can see there is flux density intensity over here. And continue the slide. We can see this is our voltage, potential volt, and this is the graph. So the graph, the voltage graph is depending to the design that we has made from the insulator. So we continue the presentation for the magnitude field intensity. So this is our graph for the magnitude intensity. So I will continue for the multiple one. This is our multiple scale for the suspension insulator. So it seems from the past one, just we put more insulator. Over here we can see around 7 insulator. So same concept as with one insulation. We'll be running the simulation and we can see the result. So for the result, I will show the plug intensity. So the field intensity, also we can see that there is several high places at the gap that show there is some fluctuation or in here, but the fluctuation is actually very less and cannot create any spark. So for uh, the what we call the graph, we can see that the graph is actually same as how the design has that we have made. So this is the graph.
Assalamualaikum and hi, my name is Mawende Afranto. I will like to explain for the analysis of FEA, simulation result and data observation. Okay, following my friend have been presented before that we have done for the single insulator design. So in figure 6.1, that is our single insulator design for our company. So we designed following the proposal that have been decided together, which is the polymer suspension type of overhead line insulator. So we construct and label insulator in the FEM design using the steel and then polymer for as the material. So in figure 6.2, above we show that the voltage for intensity of the single insulator design, that we can see that voltage intensity is located on the bottom of the insulator design. Following that, we have set that 132 kV voltage and the ground was set at the top part of the insulator. Okay, after that in figure 6.3, that show that the voltage, again the length and graph of the simulation design, it showed that peak voltage of the insulator design is 130 kV and then continuous decrease to 0. And next is for the figure 6.4 that show the field intensity for the single insulator design. As a result, that the field intensity is focused at the top and the bottom of the part is the design, but not too strong. And lastly, they have the field intensity graph, which is E against length E VM against length as figure in 6.5, which is that show the graph that rise around 60 kVA, 60 kV per m, and as have drastic decrease to 0 and then increase drastic to 30 kV dash m before dropping to the almost 0 and increase back to 30 kVm and dropping back to the almost 0 before it's rising again 90 kVA per m and drastic decrease again to almost 0. So the pattern spike of infinity density is caused by the steel and the dropping back to almost 0 as it passes the polymer insulator. So the single design is fair because it is a little vertical field pass through the insulator design. So next is for the X suspension insulator design, which is here is our for X text suspension design. We have done for the dry condition and wet condition. As dry condition, for the design for in the simulation for FEMM, that show that the voltage intensity from the figure 6.7 show that the intensity is the same as the figure before 6.2, which is the high voltage density at the bottom of the insulator where 132 kV is located at the lowest volt and the lowest voltage density at the top of the expansion is the design. So next is at figure 6.8, they show that voltage again length graph, which is they can see that 130 kV is in the beginning and then decrease constantly at 0 at the end of the insulator. So after that in figure 6.9, they show for the field intensity for the dry condition, which is as such stack is like before the one single installation result, which is they are top and the bottom for the steel and polymer of the insulator. Lastly, for the graph for field intensity against the E against the insulator length as figure in 6.10, which is result the field intensity peak at the 1.5 kV over amp and decrease to almost zero, but have continuous off fluctuation around 0.6K, 0.7K, and 0.8K and 0.9 kV per amp till the end, and finally peak again at around 1 to 4 kV per amp before then back to zero. It has the lowest value compared to the design single use because they have more special step in the design, so electric field is not easy to pass through. So next for the wet condition for our X tech for insulator design. We have done for the insulator design under the wet condition in FEMM. So we put the water drop located at the top and the end insulator. So as the figure 6.12 that show that voltage intensity for insulator design. So that is same for the result for the with the dry condition that show that highest voltage intensity at the bottom, which is 132 kV place, and the lowest intensity at the top design, which is ground. And next for the illustrated graph of voltage again length of insulator during the wet condition, and figure 6.13 that can see that highest voltage around 130 and slowly continue to drop to zero to the end. The same, still same at the as the previous dry condition. After that, the field intensity of the design under wet condition in 6.14 it showed that field intensity at the bottom end and of the insulator is when around the water droplet is also give the same result as the as such dry condition. And lastly, for figure 6.15, they show the graph of field intensity, which is again length of insulator under wet condition. So that we can see that peak like the result for the dry condition and wet condition is the same as same result that we have got. So despite for even they have the water droplet has the polyethylene, but this meaning that has X special type polymer insulator is very good. It's good even water droplet exists. The field density is still normal as dry condition, which does not allow high field density to pass through the insulator. Okay. Okay, next I will pass to the other presenter. Thank you for me. Thank you very much.
Okay. So I will explain a little bit about high voltage testing proposal. Okay, so this is our safety assessment, and our title of experiment is Mux generator for produce lightning standard with switching in fast, wet, and dry. Okay, so our location will be open space area. Okay, so this is the section 2 experiment, and this is our method statement. And this is the diagram shows high voltage testing on an insulator. Okay, so this is our experimental procedure. Okay, first mass generator is used to generate higher magnitude in fast voltage. It is also known as mass generator. And this generator uses a number of capacitors that are charged in parallel through high ohmic resistance before being discharged in series through spark gaps. And mass generator circuit used is to insulation testing for polymer suspension type of overhead line insulator. The switching is used to cut off the high current pass through. And next is for dry condition test, measure the intensity insulator strength. And next is for wet condition test, use the water droplet sprinkles on the insulator. And next is to examine the condition whether water droplet affect the field intensity of insulator. And last but not least, we gather the result data for wet and dry test. Okay, so this is our risk assessment. For our hazard and possible consequences, we have electric shock from high voltage and electricity Okay, for our experiment, we don't use any chemical usage. And so this is our hazard checklist. And this is our risk assessment severity matrix. Okay, so I will pass the next section to the next presenter.
For the code of conduct, HVAC test comprises an HVAC cascaded transformer with a temporary overvoltage as HVAC resonance set. It was selected as the electrical stress test technique. A visual corona test, a flashover test, a survival system voltage test, and other than that, in this test, the test circuit powered by cascaded transformer with voltage of 132 kV or more, and the output voltage is monitored because the cascaded transformer produces larger voltage than the straight transformer must employ a high degree of insulation. For the volume control, fake rain must adhere to strict conductivity and flow rate specification and is created by nozzle that completely cover the sample surface. Take the insulating cross-arm diagram as an example. The HVAC cascaded transformer will not, however, employ the insulation cross-arm during the overvoltage test. Each test receives the HVAC voltage for 1 or 3 times at the HV voltage typical system of the OV level. The procedure of HVAC temporary overvoltage dry and wet test. Firstly is by using a capacitor divider, it can obtain output voltage of the HVAC transformer. A short resistor is used for reducing the form extremely low current. Other than that, at the dry test and wet test, a measurement of insulator strength. Lastly, for the procedure HVAC temporary overvoltage and wet test, the examining the situation to see if there any temporary overvoltage and gather all the data. For the standard safety procedure, we have proper personal protective equipment (PPE) such as we wear a safety shoes, safety glove, wear a safety helmet, wear clothing, workshop lavatory, and we are using spectacle to cover our eye and make sure all the PPE protective must be in a good condition. And for the test object should have adequate clearance from the surrounding environment. Before turning on the power, ensure the equipment in the test area is not turned on. And lastly, make sure there is no people in the test area when we turn on the power and begin the testing. After finishing the testing, we should turn off all the power supply. For the conclusion, as the conclusion, we have followed the safety procedure conducting high voltage tests on the prototype. Besides, as a defined high current electric discharge, whose path length is generally measured in kilometer, lightning occurs when the substratum of the atmosphere attains an electrical charge sufficiently large that the electrical field associated with the charge causes electrical breakdown on the air. The testing shows similar trend at a higher voltage for longer installations, especially under the dry condition, than the flashover voltage of negative superposition is lower and thus more safe. The applied direct voltage and the current were measured at the source by the pinning supply, and to measure the voltage, the heavily damped capacitive impulse divider has been used. To measure the both DC switching impulse component, a mixed divider would be the best option. However, the damped capacitive impulse divider has proven to sufficient to accurately measure the impulse transition which is causing the flashover impulse. That's all. Thank you.